Welcome everyone. We'll be starting this webinar in a few minutes just to let everyone have time to dial in. Thank you. We're going to put you on hold for a moment until we begin. You've only got 64 people dialing. No, I agree, but hello everyone and welcome to The Changing Dynamics of In-Building Public Safety Will Affect You, and welcome to our webinar today. I'm Rich Berliner and I'm going to be your moderator. Aaron Friedman will be assisting me on the GoToWebinar board today. Just some notes before we get started. If you have a question, please ask all your questions via the GoToWebinar control panel. We will do what we can to cover topics that we think will answer most of the questions that you may have. If not, we'll answer them during the Q&A session at the end, or we will follow up with you afterwards to answer those questions. We are recording and we'll publish a link to the recording shortly after this is done, probably within a day or so. Today's slides will be emailed to everyone who has signed up, so no need to request them. During this webinar, there will be handouts that will be dropped and you may download during the webinar. If you would like more information about this topic, you can visit connectedremag.com/public safety or www.anscorporate.com. Today's speakers, and I've introduced myself, I'm Rich Berliner from Connected Real Estate Magazine. I'm the publisher. Today's speakers will be Paul Fatusha, President and General Manager of ANS Advanced Network Services, Brendan Delaney, Director of In-Building Wireless, ANS Advanced Network Services, and Jesse Holland, President and Founder of Sunrise Management and Consulting. And Jesse is an active volunteer firefighter who will provide insights and frequently ask questions to our panel, and hopefully we will answer most of the thoughts that you folks have. Today's agenda will be the evolution of public safety communications, today's challenges, technology and solutions, building owner and first responders perspective, and then Q&A. Our format will be a little different than some of you may be familiar with for this webinar. Speakers will be providing an overview of our topic, followed by a group of questions provided by Jesse Holland to help flesh out the topic from a CRE perspective, and we will answer questions from you at the end of this session. And now I'd like to hand this over to Paul Fatucha, who is the President and General Manager of ANS Advanced Network Services. Paul?
Thanks, Rich. Good afternoon, and thank you to all of you for joining our webinar today. As Rich mentioned, I am Paul Fatucha, President of ANS Advanced Network Services. ANS is a 30-year-old engineering and construction company in the telecommunications industry. We focus on 4 primary areas within the industry: in-building wireless, which includes our DAS and public safety systems, our tower construction and modification services, AC and DC power systems to support the telecommunications infrastructure, and network infrastructure in general. Over the next 10 minutes or so, I'm going to take you through the evolution of public safety in the United States and a little bit of a history lesson. On December 7th, 1736, Benjamin Franklin co-founded the Union Fire Company. It was also known as the Bucket Brigade. It was the first formally organized all-volunteer fire company in the colonies and was shaped after Boston's mutual fire societies. The difference between the Fire Society of Boston and Ben Franklin's Union Fire Company was that the Boston Mutual Fire Society only protected its members, while Ben Franklin's Union Fire Company protected the entire community. Additionally, Ben Franklin took several concepts that he observed in France associated with their fire systems when he traveled to France prior to the American Revolution War, and he brought back those technologies that he learned to implement in the United States for our fire protection systems. As years passed, various fire protection systems were developed and implemented in our country. For example, telephone red boxes, as you can see on the slide above, that had telephones on them that were attached to telephone poles. The reason for that was that so someone could pick up the phone in case of an emergency. That phone acted like a bat phone and would dial directly back to the fire station that serviced that local community. This served as our first 911 systems in the United States. In some communities, these red fire boxes on the telephone poles still exist, and they act as backup systems to the more complex E911 systems that are available today. In more recent times, the FCC's Public Safety and Homeland Security Bureau has become the delegated authority in all matters pertaining to public safety, homeland security, national security, and the emergency management system within our country. The Department of Homeland Security's Office of Emergency Communication, in collaboration with SAFECOM, the National Council of Statewide Interoperability Coordinators, the National Fire Protection Agency, the International Fire Codes, and the public safety officials at multiple levels throughout the government in the country help drive the policies and code regulations and processes associated with protecting the people of our great nation. The public safety community has made significant strides towards strengthening and improving our emergency communications capabilities. First responders, however, continue to be limited by fragmented network and decade-old wireless systems. As you will find out later on in our presentation, Jesse has some examples of how this is still happening today. Deploying a cost-effective nationwide public safety wireless broadband network, or FirstNet as it's known as, will provide public safety agencies with advanced cutting-edge technologies and applications to improve their emergency response capabilities. In February 2012, the Middle Class Tax Relief and Job Creation Act, better known as Public Law 112-96, authorized the development and implementation of the National Public Safety Broadband Network, NPSBN as it's also known. The law also established the First Responders Network Authority, which is FirstNet, and it has implemented the governing body associated with that organization that also manages the NPSBN. Additionally, it set aside $7 billion initially for network development, deployment, and operations. And it has also assigned the use of the 700D block spectrum to FirstNet for the public safety community. As envisioned, the network will incorporate open wireless technology standards that are being deployed today by the wireless carriers in the United States. The NPSBN is closely aligned with the commercial deployments of long-term evolution networks, better known as the 4G LTE networks that the wireless carriers are building today, to keep pace with the technological changes and to leverage cost efficiencies. This newly deployed network must embrace levels, availability, and robustness found in today's public safety land mobile radio or LMR mission-critical voice networks to deliver wireless data services to the public safety agencies in the federal, state, and local jurisdictions across the nation, as well as to federal responders and secondary users such as transportation departments and public works departments, just to name a few. If there is any convergence of these networks, the federal, state, and local agencies, in conjunction with private sector entities, must work together to develop requirements and standards to ensure mission-critical voice and data operations. In the near term, wireless broadband will complement the LMR networks, not replace them. Commercially available wireless broadband services under development today do not currently fully meet the requirements of the emergency response voice communications. Therefore, the LMR networks will remain as the primary voice communication services for public safety for the foreseeable future. Investments in the LMR will continue to be necessary. Public safety's use of the LMR systems will continue for the foreseeable future, as there is no defined time frame when the 4G LTE broadband technology may be provided by the carriers that would supply the same level of mission-critical voice services that are available today. Therefore, it will be necessary to continue investments for existing and new LMR voice systems while allocating new funding to the development and deployment of the NPSBN network. And Brendan, a little later on, is going to talk about some of those systems that are available today. Public safety is using commercial broadband services today for many different data applications. For example, the National Crime Information Centers, the state criminal justice information systems, and various computer-aided dispatch information systems utilize today's commercially available broadband technology. Although initial data applications will not provide mission-critical LMR-type voice services, these data applications are vital and can dramatically improve emergency response and the provision of the public safety services. In the future, broadband will be able to support mission-critical voice services. However, requirements must continue to evolve and new equipment and services built and tested for operational readiness and compliance in the challenging public safety environment will continue to happen. Until broadband is technically capable of supporting public safety mission-critical voice communications and the NPSBN is fully deployed, the public safety agencies will need to continue to use current LMR networks for their mission-critical voice communications. On this next slide, we're going to talk about the vision of the evolution of the public safety communications as it transitions from today's technology to the desired long-term state of convergence in this depicted slide. This slide outlines the framework for deploying nationwide wireless broadband communications while maintaining the LMR networks to support mission-critical voice communications. In the current state of communications, LMR networks, commercial broadband networks, and the NPSBN are evolving in parallel, as you can see depicted on the screen. As communications evolve, public safety will continue to use the reliable mission-critical voice communications offered by the traditional LMR systems. At the same time, though, agencies will continue to implement emerging wireless broadband services and the associated applications. During the transition period, FirstNet, in conjunction with public safety, will build out the NPSBN network, and the public safety organization will begin to transition from commercial broadband services to the dedicated public safety network. When the technological and non-technological requirements are met and are proven to achieve mission-critical voice capability, it is anticipated that the agencies will then start to migrate partially or entirely over to this new FirstNet broadband technology network. It is critical for all levels of government to proactively and collaboratively develop policies and plans for emerging emergency communications technologies. With the establishment of FirstNet, there is a nationwide governance structure that will collaborate with the federal, state, and local agencies to develop new initiatives, strategies, and timeframes related to investment and deployment of the NPSBN network. FirstNet has also established the Public Safety Advisory Council to assist FirstNet in carrying out its duties and responsibilities. I am now going to turn the stage over to Brendan Delaney to talk about today's challenges from a technology and solutions perspective.
Thank you very much, Paul. My name is Brendan Delaney. I'm the Director of In-Building Wireless for ANS Advanced Network Services. And Aaron, if you could swap to the next slide, please. The code recommendation slide. All right, and for codes for in-building public safety and fire protection are driven by the National Fire Protection Association, or NFPA, and the International Code Council, ICC. The National Fire Protection Association codes that dictate the requirements for in-building public safety radio coverage are the NFPA 72 and the NFPA 1221. The International Code Council issues the International Fire Code, or IFC. The codes are similar, but the NFPA versions tend to get a little bit deeper into the details of what is covered, how, and construction methods, whereas the ICC allows more input and interpretation by the local authorities having jurisdiction. An authority having jurisdiction is very much what it sounds like, or AHJ. It's the individual in your jurisdiction who has the authority to implement and enforce codes. Typically for fire safety, this is driven by the Building Code Enforcement Office or by the fire marshal, or a combination of the two. There are increasing numbers of jurisdictions requiring in-building first responder radio system coverage for new and also existing buildings. These requirements are enforced by making the issuance of the certificate of occupancy at the end of a project contingent upon having the required in-building coverage. Whether your jurisdiction utilizes NFPA or IFC codes depends on what has been adopted for the overall building codes for your area. The adoption of these codes started with major metropolitan areas such as New York City, Washington, D.C., and Miami, with statewide adoptions and regulations as well, and some examples of those are the state of Florida. Ohio released statewide recommendations, and California has for quite some time. When the state codes are adopted, enforcement can vary based on how the local authority having jurisdiction interprets these requirements, and a lot of that's based on what sort of area of the state. A more metropolitan area will interpret that code differently than a suburban or a rural area of the state. The currently published revisions of both the NFP and the IFC code recommendations do not currently cover the FirstNet LTE coverage that Paul was speaking of before. This is planned for future releases, but how it's interpreted in those releases is going to be very dependent on how that rolls out over the next several years. Aaron, if you could move to the next slide. Getting into the more technical side of the code recommendations to help familiarize you with the types of systems that you may require, battery backup for the first responder radio system is crucial, as this is a life safety system that needs mission critical support. The codes currently being enforced by most jurisdictions are not the latest revision due to the typical delays in local review, support, and adoption of the different codes. There's a lot that goes into the review of the codes to make sure it's going to fit everyone's situation. The currently revision that's enforced by most municipalities requires a 24-hour battery backup system. However, the latest revisions of the NFPA and the IFC codes has decreased that backup time to 12 hours. The battery backups typically need to be in a NEMA 3R or 4 rated and UL rated enclosure. There are also dry contacts on these battery backups, as well as the bidirectional amplifiers that get integrated into the building fire alarm annunciator panel for both awareness at the annunciator panel when you walk in the building, as well as in the overall monitoring systems of the fire alarm systems. The rule of thumb is negative 95 dBm over 95% of the building for required signal strength, but 100% of critical areas being covered. And those critical areas consist of mechanical spaces and stairwells. Additionally, the code requires certain levels of delivered audio quality, or DAQ, and thresholds of bit error rate for digital systems. For assessing the coverage levels inside a structure, a grid test is performed. On this slide, you can see a screen grab of a grid test recently completed by ANS for one of our projects, and also a handout for a solution brief of this project will be distributed as part of this webinar. You can see the grid layout in yellow on the floor plan, and each grid location tested for the required key performance indicators, and compliance is noted in a color-coded legend. Throughout the grid, an engineer utilizes a spectrum analyzer as well as an appropriate two-way radio to collect the performance data of the two-way radio system in that area. The grid tests are performed during the assessment phase, which can be completed anytime for an existing structure, but on a new building, it's critical that the walls, windows, and any exterior treatments, such as EIFS, metal cladding, etc., are in place prior to having this test performed. The low E glass in windows, as well as many of the modern building exteriors, are excellent reflectors of RF signals, whether those signals are the first responder radio system or the mobile phones that your tenants and yourself utilize on a day-to-day basis. Starting with that upfront grid test, it's important to contract with an experienced integrator who understands the code requirements, who to talk to in your specific jurisdiction, what the frequencies and technologies that are being utilized in your jurisdiction are, as well as how to design and deploy an in-building DAS for public safety. After the system is installed, commissioned, and confirmed to be working with the authority having jurisdiction, a system acceptance grid test is completed. This is done to ensure both there are no more issues inside the building where first responders wouldn't be able to communicate, as well as to validate that the system is performing as it should be. Once the system is in place, there are ongoing maintenance requirements similar to any life safety system in your building. Both the NFPA and IFC require annual maintenance consisting of, at a minimum, grid testing, battery system testing, and alarm verification to ensure that any trouble issues are being properly communicated to the fire alarm system, annunciator panel, and monitoring system. Next slide, please. It's a fairly standard set of solutions to address in-building coverage issues for first responder radio systems. The industry is largely reliant on bidirectional amplifiers, or BDAs. A bidirectional amplifier is very much what it sounds like. It takes the outdoor signal in via a donor antenna, which is typically on the roof, amplifies it and filters the signals, and then distributes that signal throughout the building via a passive coax and antenna system or a system utilizing leak coax. And the signals from the inside follow that opposite path back out to the public safety tower that is serving your area. These address coverage issues with most buildings or areas where the coverage is lacking, as a bidirectional amplifier will support up to approximately 200,000 square feet. This square footage is based on the actual BDA amplifier, bidirectional amplifier that's specified for the system, its output power, the local requirements, as well as the building configuration, such as the material that the walls are made out of and the number of walls within the space. For larger spaces or spaces featuring very dense construction, a lot of concrete or numerous walls, a fiber distributed antenna system, or DAS, can be deployed. This solution consists of a bidirectional amplifier feeding into the DAS head end. This signal is then turned into an optical signal, which is distributed typically to IDFs via single mode fiber. At the IDFs, it's transformed back into RF for the public safety radios to utilize. As discussed previously, the battery backup is a key aspect of the public safety radio system to ensure that it is mission critical in nature. These battery backups need to be in the NEMA rated enclosures and are typically UL rated, as well as the bidirectional amplifiers and any distributed antenna system equipment must also be UL rated and in a NEMA enclosure. Whether you have a bidirectional amplifier alone or a fiber-based DAS, that connection back into the fire alarm panel is also key. Next slide, please. The NFPA and IFC codes require coverage for first responder radios, but this is only part of the equation for having a truly safe building for the general public. As we all know, we live in a mobile-first world, and we're becoming less and less reliant and also less and less aware of the wired infrastructure around us. This raises the question of, can the general public communicate in the event of an emergency inside your building or structure? And the likely answer is that if your building is lacking first responder radio coverage, you're also lacking sufficient mobile phone coverage as well. This is due to the same issues with building construction, low E-glass, and building facades that affect the first responder radio signals. Next slide. The ways to address wireless carrier coverage can be similar to the solutions utilized to address the first responder radio systems. It's typically required by the authority having jurisdiction to have any first responder systems and wireless carrier systems on completely parallel infrastructure due to the different levels of mission critical nature between those two systems. And it makes sense for the building owner as well, because if you're to add the additional backup power required to support both systems on the same platform, that greatly increases the amount of battery backup and cost you would incur. A quick overview of these solutions is a distributed antenna system utilizes a centralized head end that takes the wireless carrier signals in and transforms that signal into an optical signal. That's distributed via single mode fiber to the remotes, typically located in IDF closets, and those remotes take the optical signal and put it back into an RF signal for distribution through coaxial antennas to your phone, handset, or tablet. The trick of a distributed antenna system is that you're very dependent on wireless carriers approving the design, budgeting their funds to support the signal source equipment for that DAS, as well as securing backhaul fiber connection into your facility. All of these can affect your timeline of being on air, as well as remove some of the control that a building owner would have over the system that they're paying for. Small cell systems can utilize the building internet connection via a VLAN or a simple outbound internet connection. The network topology of a small cell system looks very similar to a Wi-Fi, where you have a centralized controller at your MDF, and then you have PoE switches in your IDF closets and category cabling out to the radio nodes. These solutions provide LTE or 4G connectivity for enterprise environment. In certain situations, they can be used as a signal source to feed a DAS, bringing a little bit more control back to the landowner. The trick is that today, each carrier requires its own layer of small cells. So to have multiple carriers in your building or space, you would need to have multiple radio nodes in a similar area. Boosters can be a good fit for smaller buildings in suburban and rural environments. The simplest description is that these systems take a signal from outside and boost all manner of carrier signals into the building via coaxial antennas. This is contingent on usable signal levels being outside, so if you don't have coverage outside your building, there would be nothing to boost. Also, in denser or urban locations, there may be too much signal or too much noise and congestion outdoors to effectively boost the signal indoors. These systems are typically sold in kits consisting of a donor antenna, the booster, and the indoor coverage antenna. And this is per FCC guidelines, as it's meant to be more of a consumer-facing system. Next slide, please. And the FCC has specific 911 calling requirements that it holds the carriers to, and the wireless carriers are required to put through a 911 call if there is no other carrier signal available, such as for your own phone. This is contingent that the person or your device trying to make the 911 call having a compatible technology to what's available in the space. Today, the phones you purchase from 3 of the carriers, AT&T, T-Mobile, and Verizon, are capable of supporting voice over their 4G networks, otherwise known as VoLTE or voice over LTE, as well as their legacy 3G networks, so that the phones would be interoperable across those carriers. On the other hand, Sprint, as of today, has not enabled voice over their 4G networks. They only support voice on their older 3G networks. So older technology would have to be present from the other carriers for that discussion back and forth. And now I'd like to hand it off to Jesse Holland.
Hey, Brendan. Hi, Brendan. Yes. Before we jump to the next one, we do have a question. How do we determine what our AHJ has adopted? Can you speak to that really quickly?
I'm sorry, Aaron, I lost you for just a second there.
Can you just speak quickly to how one can determine what their local AHJ has adopted?
Absolutely. The first step is to have a conversation with the AHJ, and this would typically occur at the time you're doing your initial code review on your project, whether it's a expansion inside your facility, a new building, when you're working with your architects and engineers up front and coordinating with the municipality. You would want to ask these questions about, is two-way first responder coverage required inside my building? If so, could you share a copy of that code? Because it's not necessarily going to read verbatim what's recommended by either the NFPA or the IFC.
Perfect, thank you. Jesse, I'm sorry, I didn't mean to interrupt.
Not a problem. My name is Jesse Holland. I'm the president of Sunrise Management Consulting. So that is my property management hat, and I've also been a volunteer firefighter EMT for the last 19 years. So I have an insight into that part of the world also. You can switch over to the next slide. From the property management standpoint, we look at this whole system and connection as part of our disaster planning, or needs to be part of our disaster planning when we're managing a property. Rich, can you switch over to the next slide? No. So when thinking, we make sure we create a disaster plan for each property we manage, and the planning of that, or the looking into that, encompasses coordinating with the local fire departments and with public safety for their response as well as their needs. Making sure you have just some best practices, keeping a printed copy of that plan available, not just an electronic copy, because that may not be available. And especially with disaster planning, is incorporating a public relations piece or strategy into that, and thinking about how it's going to play with your tenants, what you need to be prepared to handle. And we also look at it, updating those annually. So from the property management perspective, my first question on this is, what are the responsibilities of the property manager with these new laws and these ever-changing systems?
Mm-hmm. For your existing buildings, and I think part of that disaster plan they mentioned, that's a great best practice to have there, and it would be good to include communication with your municipality, especially if you have an existing system. I would team it right up with your life safety maintenance side of things, testing of the updated grid testing, the updated or the testing of the battery backup. You should also have that same integrator that's performing that testing coordinate with the AHJ in your area to make sure that if there are any changes, what they were, so that the system can be amended to make sure that you're covering all the EMTs, fire and police responders that could be coming to your facility, as well as making sure that you're keeping up with the technology, as well as asking them about what's coming down the pike. If they're moving from a 450 megahertz UHF-based system to a 700 or 800 megahertz two-way radio system, that would be very important because that's a completely different bidirectional amplifier that you would need. So having that ongoing communication with the AHJ and contracting with an integrator who knows to ask those questions is very important.
Excellent. So with my firefighter hat on, when I arrive at a property, how am I going to know that communication is available in the facility, that there's something there that's going to help me or hurt me?
Okay. From the NFPA and IFC side of things on both code recommendations, having it tied into the building enunciator panel was a very intelligent move for both of them because, in theory, when you're walking into the entrance of a building, provided that space is available, you're checking that enunciator panel to see if there's trouble, where there's trouble, and the dry contacts that are fed from the bidirectional amplifier and the battery backup are also shown on there. So you can see very quickly if, say, there's no commercial power, but there's still battery backup available on that bidirectional amplifier, you know that. It'll also there's a alarm on the dry contacts to show if there's less than 30% of battery. So walking in there, you can see if it's on its last 30% of battery, you know that you have a limited window of how long your two-way radios are going to work for. So that's the first step is to look at that enunciator panel.
Excellent. And what happens if there's multiple radio systems in a jurisdiction? I know we operate in Schenectady County, and some of our mutual aid departments are both in Albany and Schenectady County, which can make for some very confusing radio traffic.
I could understand that, and you never want to have confusing communication at any sort of emergency response. And a lot of that goes into the upfront planning because in that area you're speaking of, you're right in the board in between two municipalities. So you have to take into municipalities and counties. So you have to make sure that you're planning properly for both the county you sit in as well as the adjacent folks who would be responding to an emergency potentially because you may be closer to where they dispatch out of than your home fire department or EMT.
And if there is a fire, one of the first standard operating procedures is to cut power to the building. How is that going to affect this radio system?
Mm-hmm. And that's where the battery backup is incredibly important, and the maintenance of that battery backup, because any sort of battery is only good for so long, whether it is meant for a public safety mission critical application or it's the double A's in your kid's toy. That thing is only going to work for so long, and it's incredibly important to have that as part of your annual maintenance procedure to test the load carrying capabilities of that battery, both from shutting off commercial power to your bidirectional amplifier and battery backup to make sure it transitions properly, as well as doing a load test on that battery backup to ensure and extrapolate out how long it will actually be good for, because over time, that initial 24 hours that it was designed for, depending on the battery, 3 years out, 5 years out, that 24 hours will quickly slip down to much less than that.
So putting my property manager hat back on, so it sounds like the fire alarm panel is the central hub of this system. What are some of the things I need to think about, either when I'm speccing a new building or when I'm looking at existing alarm panels or replacing alarm panels to what should I be keyed in on?
Okay. So for any of the new panels and new platforms that are out there, because this has become such a prominent piece of the code, most of the commercially available panels for new purchase have this ready to go to bolt on to support these additional dry contacts and also show its performance at the enunciator panel. However, if you have a legacy fire alarm system inside your building, that would take some coordination with your fire alarm vendor to see if your local municipality begins requiring this. Will you also need to upgrade that panel so you can plan appropriately for budgeting purposes and also to really understand what that upgrade will entail, because it could be a lot more than just the panel that needs to be upgraded. It could be the smoke heads, the integration with the sprinkler system. There could be a lot more than just the annunciator panel that requires an upgrade to an existing building.
Got it. So it sounds like I'm enhancing my my life safety system significantly. Do you know if there's any kind of credit or reduction in my insurance costs for this?
Sure, Jesse. The real key here is to talk to your insurance company to find out what kind of programs are out there. We have pulled a couple different insurance carriers in this area, and they all have a credit to your insurance cost based on having various types of fire protection systems in the building. Whether it's a sprinkler system or a fire system, they do offer credits. As these technologies that enhance the coverage expand, what I was told is that there could be potential credits in the future as well for some of the broadband technology services that are going to get incorporated into these networks.
Excellent. So I'm going to spend a lot of money to do this. I may have to because of code. Obviously, there's some benefits to with my tenants to making sure their cell phones work. Do you feel there's some kind of competitive edge I can gain in putting these systems in or working with these?
Sure. I'll put my marketing hat on, as you've asked, and what I would say is that knowing the environment that you own your facility in is critical in being able to leverage these systems in your facility. So if you are a landowner and have a building that does have these systems in there, and the guy next to you does not, I would definitely leverage that when people come in to try to rent your facility. Also, there are some advantages now today with some of the contracts that are getting written for real estate owners where they actually can take advantage and put that in their contract as part of a service that you're offering in the facility to better, make your tenants safer.
Okay. And as you guys talked about, this has to be inspected on an annual basis and maintained just like a sprinkler alarm system. Who's responsible for those inspections? How does that happen?
Okay. It's the first and easiest response is you can contract with the company that did the initial design and deployment of the in-building system for the building. But there's numerous integrators in any market that work with these public safety systems that have experience, but it's always important. The lowest cost is not always the best option here, because you definitely want to make sure it's someone who's meeting the AHJ's requirements for what deliverables have to be turned over on a year-by-year basis, because most of the authorities have a jurisdiction require that grid test is provided to them to show that it's actually been completed, as well as a hard copy of it is kept at the facility with the rest of the certificates of inspection, as well as results from the battery backup. So you definitely want to make sure you do your homework in terms of understanding the integrator, their skill set, to make sure that they can check all the boxes and respond also as needed. So having someone with a local presence is also helpful.
Excellent. And if public safety does make a change to their radio system, is it their responsibility to tell us? Is it our responsibility to know it? How does that work?
It's still a bit of a gray area, and that's why that annual inspection and the communication therein is key. You definitely want to make sure you ask those questions to the AHJ so you can understand what's happening out there. So not only you have a system, but the first responders can actually communicate on the system you own.
I often find that helpful. And is there any kind of notification in these systems so that I would know that it's not working as the property owner, so I would know that I'd have to fix it or know there was a problem?
You can both. There's two different paths to address that. The first is you can actually have a separate monitoring and platform on your bidirectional amplifier that's pulling the same information of the dry contacts and providing it to you directly as part of that parallel platform. You can also, if you have automatic notifications on your fire alarm panel going to either the network operations center of your fire alarm provider or providing emails directly to you. Those are the two options on how to do it. Whether you can collapse it onto one platform or have a parallel one is really up to the other systems you have in your building.
Excellent. I think that takes care of all of my questions. Gives us a good start from the property management side in understanding these new laws. So, thanks, Paul, and thanks, Brendan.
This is Rich Berliner. If we have any questions from the audience, we'd like to get them now, and you may send them in through the control panel. And if we get any questions, we will ask them of the panel. And Aaron, do we have any questions yet?
We do have one more question. I think I would direct this one to Brendan, if that's okay. Brendan, if a code we're talking about the public safety system, is it considered a code requirement that this type of system be installed, or is it a recommendation at this point? We keep talking about NFPA. We're not sure that the person asking the question isn't necessarily sure if it's required for their location. How are we differentiating the difference between those two?
That's a great question, and it can be very confusing when you're talking about the NFPA and IFC, because those are recommendations, and then it depends on what your municipality puts in their code as to what the requirement is. Because you can have a state like Florida where they've taken very much the NFPA verbatim and turned that recommendation into a requirement. And they've also interpreted in certain municipalities to actually be more stringent than other folks reading the code have looked at it. So really, it's up at that national level. It's a recommendation, but your local code is the requirement. And then you have another. New York City is a different example. They went ahead and developed their own code that is independent of the NFPA or the IFC that deals with the public safety situation that they have down there. It's very much tailored to their own 450 megahertz system, as well as how it's addressed in pretty much each and every building, or assessed in each and every building inside of New York Metro. But in terms of figuring out for your jurisdiction, it's about having a communication with your code enforcement folks, or working with an integrator who is local or knows the right questions to ask where you live, and reach out to the right personnel.
Awesome. So we got a whole bunch of questions coming. I'd just like to address them to you guys as a group, if that's okay. And whoever you feel is best to answer it, we'll go from there, if that's okay. So the next one is basically talks about, study indicates that LMR and LTE systems can basically coexist. But how do we have to consider engineering purposes regarding interference?
Okay, and that's another very good question, because there are concerns about interference between some of the public safety frequencies and the carrier frequencies, especially in that 700, 800 megahertz area, because they're neighbors very much between the carriers and the public safety there. So that's addressed both on the upfront engineering side to make sure that you don't have too much power in either of those systems that it would drown out the other. It's also addressed via some filtering, actual physical pieces of equipment that go in line to make sure that everything stays within its lane, if you will. So it's something where you want to consider that up front, so that you're not surprised when you go to turn on your system and you have degradation of either or both your public safety and your carrier system inside the building.
Thanks, Brendan. I guess I'll go on to the next question. The next question is, I think this is a great question that definitely we should take a few minutes and talk about. Can we superimpose a public safety system on a current DAS or a Wi-Fi DAS system? or does it have to be a standalone system?
On a Wi-Fi system, it's really not, it's apples and oranges there in terms of the technology and how it's distributed. If you have an existing system, it's physically possible depending on the frequencies you're working with, but the code enforcement may require it to be on different parallel paths. We've worked in a government facility in our footprint where there was an existing carrier DAS. The authority having jurisdiction came to us and said, okay, we just upgraded to an 800 megahertz system and now our radios don't work in the subgrade levels. But there's this existing infrastructure. We'll approve co-locating these two facilities together, but it was a parallel set of remotes at the IDF closets and a parallel head end, so that it's sharing some of the antennas out in the field, but the infrastructure is still very much separate in terms of the critical pieces that are distributing the signal. So it's kind of a long and gray answer. Physically possible, but a lot of it requires approval from your local authority having jurisdiction, because some AHJs just will not have, never the two shall meet in terms of the coax and antennas or the equipment that's distributing the signal, the bidirectional amplifier or the distributed antenna system equipment. So there's the concern about the interference as well. And the IDF, I apologize, I keep throwing that acronym out there. It's your IT closets that are distributed throughout the buildings. You have your main closet where essentially all the carriers bring their fiber and their copper systems into your building, and then you'll have either fiber or copper going from there to the individual data rooms inside your building and via the riser closets or conduit. So hopefully that addresses that. I apologize for the acronym there.
Perfect. Thank you, Brendan, again. Paul, I guess this one's for you. Can you clarify, are insurance companies giving credits already, or are they talking about they may do that in the future?
No, so the insurance carriers that I talk to will give you a credit on your insurance based on the fire system that you have in your building. It's not directly associated with the radio system. It's more the fire suppression system and sensors associated with that.
Awesome. Again, thank you for that insight. Two questions in one, guys. What are we doing to protect the fiber / coax? Because that's going to remain vulnerable. Is that going to be hidden in EMT conduit, in the risers? Is there a backup system for the fiber coming into the system?
So the fiber and the coax, depending on how the code is being interpreted, but one of the popular interpretations is for pathway survivability, which is included in the NFPA and defined therein. A lot of it, if you're sticking within the riser closets or 2-hour rated spaces, you don't have to put it in an EMT conduit. But if that riser or trunk fiber is going to be outside of a 2-hour rated space, then it would need to be an EMT conduit. But typically for the coax and the antennas, if it's just a branch coax, which is coming out of the riser or the telecom closet going out to a single antenna or a couple antennas, that would be a horizontal, and it would not have to be in a survivable pathway, which would be a 2-hour rated structure or an EMT conduit, because ultimately, at the end of the day, what's distributing that signal and making it work for the two-way radios is that antenna at the end, and it's a fairly fragile object. It's not there's no 2-hour rating of an antenna that exists on the market today or anything like that. So that's your weak spot.
The other piece, just if I may add, you also have to define if the cables are run in a plenum area. If they are in a plenum area, then they have to be protected or be a plenum rated type cable. If they're not, then you could just use a standard cable.
Awesome. Thank you, guys. Final question I have is there a list of states or jurisdictions that currently have, that we know are enforcing that code? Or is it changing every day and just evolving?
It is changing every day, but there are certain industry organizations such as the Safer Building Coalition that does their best to try to keep up with the states and jurisdictions that are adopting these codes. So, but a lot of it really has to deal with the ongoing communication, whether upfront in a project, whether that's a renovation or a new building, as well as on an annual basis with your code enforcement folks for your life safety systems.
Gentlemen, thank you so much. I think we've exhausted all the questions we had. I think that was a terrific analysis of this situation. Thank you all for attending. Those of you who listened in, again, you will get a recording of this within a day or so. And we hope you listen in for our webinars again in the future. And thank you all for attending today. Goodbye.